Question number 15. Now that is a significantly more difficult than number 17. Here we have a projectile that is launched at an angle of 40 degrees to the horizontal. Mine is puny, not quite 40, but whatever. 40 degrees, and the actual speed is 12 meters per second. The height from which it was launched is 1.80 meters above the ground. Shot put travels all the way to the ground, and what we are required to find is this change in x. Now, as opposed to simple examples where you have something that is launched from the ground and falls all the way back down, we used to do that as finding half time, then multiplying Vx by that double the time. In this case, it's sort of easier and sort of not. We have to still do our first step of h and v separation. So Vx, which is the horizontal component, which will not change throughout the flight because we disregard air resistance, is going to be 12 times cosine of 40, 9.2 meters per second, whereas Vy initial, and I have to say initial because it will change, is going to be 12 sine of 40, 7.7 meters per second. What else do I know? I know G, and now I have to make it negative 9.8 because it's downward, where 7.7 is upward. So negative 9.8 meters per second squared. Horizontally, I do not know my change in x, but I can find it as Vx times change in t. So I'm after change in t. To find change in t, I'm going to use the equation change in y equals V initial, obviously y, because that's vertical part, minus, well, technically I'm going to say for the full purpose of the exercise, 1/2 g change in t squared. Obviously it goes all the way up, then it goes back to this 1.8 meters above the ground, and then it falls the other 1.8. But ultimately, this is the start, this is the finish, and vertically, our ball or shot put, whatever it is, travels negative 1.8 meters. Negative because it's downward. So I can just do that. I can do negative 1.8 equals 7.7 t minus 4.9 t squared. Use Desmos or your calculator, or if you're into discriminant, go for it. Knock yourself out. I'm just going to do 4.9 t squared minus 7.7 t and minus 1.8 equals y. I'm going to graph it. I get two results for t, but the negative result is not going to cut it for me because I know time cannot be negative. So I'm going to pick the one that is positive, which will be 1.78 seconds. That tells me that it will take 1.78 seconds to do what? To go all the way up, back to this, and then the other 1.8 meters. So then change in x will be 9.2 times 1.78, 16.4. So change in x equals 16.4 meters. And that, ladies and gentlemen, is the answer to question number 15. You're welcome.